Okay, so the next thing we need to do is check to see if the character is out of range, so less than 33 or greater than 127 of the characters that we'll be using. If it is, then we'll just treat it like a space, and we'll advance the position, increment A and continue. Look at the width and height of the current character we're looking at. Though the right side of the character at the current position is greater than what rightmost currently is, then we'll update rightmost to be the position plus the width of the character. We'll apply the same concept in the vertical manner. Py plus h, this will be bottommost. And we'll advance the px position by width divided by 2 plus current space. So we'll return new vector 2, rightmost, bottommost. And then we'll have the width and height of the paragraph or the string that makes up a paragraph. And that way we know what kind of graphical backdrop, what size of graphical backdrop to use so that those letters will fit into it. So let's start a drawString method. Fast forwarding a bit, I added a comment here. Regular accurate drawString method for when you need precision. We'll take a string for text, position, a size or scale, color, alignment, how do we want to align it? None by default, if we can specify it. If begin wasn't called, okay, so paste that in from the other ones. If there's no font text loaded, that means we haven't loaded the texture for the font, which shouldn't happen. Set px and py, the starting position. I don't know why I put this twice. Spacing will be, we don't need to go x2 minus x1, we can just say fd32w times scale.x. Vertical spacing, which will be fd32.h, we'll subtract 2 from it, times scale.y. And the current space is going to be spacing divided by 4, w, h, width height, x1, x2, 2 by 1, 2 by 2. We'll see what these are for in a second. So in the situation where align not equal to alignment of none, so in other words, it does have some kind of alignment, then we'll see if the alignment is left aligned, in which case position x, start off with spacing plus px equals spacing, one space from left side of the screen. So it's going to align on the left side. If it's not left aligned, we'll set max x and xx to px, the current position, and we'll start a loop while q is less than text length, and the x is updated as w divided by 2 plus current space. If maximum x is less than xx, then we'll say max x is equal to xx. So we'll get the character if it's carriage return or whatever. Set the current x to be the starting position x. Prepare for continuing. If c is less than 33 or c is greater than 127, we'll treat it like a space. Plus places here. So x equals spacing. II is equal to int c. W is equal to fd by I.w times scale.x. So let's put this on a different line. Okay, so what we're doing is we're starting max x off at position that we want to write text at, and we keep updating the x position in the text to see where the maximum right side of this text is going to be. Maybe a carriage return that may come back, so you can't just use the quantity of characters in the text to determine that. You could make an alternative version of this where it just assumes that there's no carriage return. So the whole point of this basically is to figure out where the maximum horizontal position is for the text that's going to be written. The text width is going to be max x minus px. The rightmost text position and the leftmost text position subtracted gives you the text width. Now we can say if alignment equals alignment, center align. We know to draw it at screen width divided by 2, which is the center, minus the text width that we calculated. And then we'll put the position to draw it is equal to that new position calculated. Else, if the alignment is right aligned, then we'll say that the position is going to be the right side of the screen width, minus the text width, minus a space. So now we can begin the process of looping through the characters in the string and figuring out how to actually draw each one. So start a loop, an a++ loop, while a is less than text length. The position is going to be updated by width divided by 2 plus current space. And we'll set the width up here. We'll get the first character. if it's a carriage return, and we set the position to be the starting position, and we go one space down, and continue. And if it's out of range, then we move ahead by a space, or treating it like a space, go A++ and continue. Now we can get the width, which will be needed down here. It's IW times the scale that we want to draw at. Same sort of thing for the height. We scale it based on our parameter that we are using here. Then we can get the texture coordinate for the top left, which will be FDI x1 divided by the font text width, FDI.y1 divided by the texture's height. So texture map position, or the U for the bottom right hand corner, is going to be x2, and for the y divided by the height to get it in terms of 0 to 1. So now we have the texture coordinates for the font that we want to extract off the texture map. So our position is our current character position, and we just use our current default font depth. Copy this line down and set a position. This is going to be texture coordinate, and this will be a vector 2 because it's in UV space. There's no depth, and this will have to be the upper left of the font. We can also set the color. Color is equal to color. Later on, if you wanted, you could make a gradient version of your drawstring and just have a bunch of different colors, or maybe 2 colors if you just wanted to change or fade in the vertical direction or something. And we should also tell it that we're working on the next vertex. Font vert count ++. This will be the upper right, which would mean, oh yeah, we need the position here too. So the position of the upper right would be tx plus w, and the texture coordinate will be tx2 ty1. Copy that again, and this will be lower right. So then we can just add plus h here and change this to y2. And for lower left, this would just be px plus py plus h. This would be tx1 ty2. And in case we reached the maximum number of vertices for drawing fonts, end font, we can call end font. Make sure being called set back to true, and font vertex count is going to be set to 0. Oh, I got too many brackets here. Okay, that's the more precise version of drawstring. So let's copy our drawstring method and make a faster version of it that doesn't deal with alignment. And we'll call this one drawstring fast, just to make a clear distinction. For this one, we're not going to bother with scale. We can set the default scale too if we need to. Also, we'll start this off with average width, half of it, added on there, so there's part of a space added onto the front of it. That's a floating point. And our spacing, we'll say W and 0.5. We can actually just go by W. So that's half the width of a character, which is going to be quarter width in a second here, because we're going to times it by 0.5. So our spacing is half the width, but first we got to scale it by default font size, and times 0.5f. Then we can say the vertical spacing is the same thing, height minus 2, and then we're going to go times default font size. You might have noticed that I'm just sticking to regular scaling and drawstring without factoring in a default font size, and then just using default font size now only for the fast drawing stuff. So that way you never end up having to specify. Just as a little extra explanation about the spacing, you'll notice that any one of these characters, regardless of how wide they are typically occupying about half the horizontal space, like if you were to move this over to the edge, and then you add the kerning that you want for the space between each letters. So that's why we're timesing them by half the width, because the width is for the entire box. And if you were to add the spacing on top of that space, then the letters would be spaced apart too far. As far as vertical spacing goes, we can use the entire height, because when you finish a line of typing and you go down to here, that should be okay. If you wanted them a bit tighter, you could adjust it in a similar sort of way. So by default, the current space is going to be a quarter of what the spacing is, and that generally works out pretty well. Instead of adding the current spacing in each time in the drawstring fast version, I'm just factoring everything in here all at once. So there's no alignment options. We can get rid of all that. What we may want to record though is some multipliers for getting the texture coordinates in UV space. Although nowadays I don't know if this sort of technique is actually any faster on most processors, but at one time it was. But just in case, it doesn't hurt. And we'll calculate height ahead of time, scaling it by the default font size. They're all going to be the same. Height doesn't vary. Okay, this stuff's all the same. Our width, or our height doesn't change, as I said. And we're going to default font size for the width scaling. For texture coordinates, we're going to multiply this by inv width. And that'll put it from 0 to 1 so that the shader can handle those UV coordinates. Let's copy this down to here. Say 2 is going to be x2 to y2. So this will start off as px minus w. We're going to say minus w because we're handling the kerning a bit differently this time. Then plus w for the right side, obviously plus w here and minus w here. Texture coordinates are identical to what we had before. So instead of this, we're changing this now to plus equals spacing. So we've simplified it a little bit. The math should be a little bit more efficient, and the fonts should be in fairly accurate positions on the screen as to where we'd like to see them. So if we want a scale version of this, where we specify the scale as part of the method, not wanting to actually change the default scale, but we just want to temporarily change scale for a single line of text or something, we'll just copy and paste this, say scaled, add the scale in here. We'll adjust this adjustment by scale, and okay, we'll just factor scale onto spacing, and we can do the same thing here. Oops, times scale, and we'll factor our scale here so that our height is adjusted, and we'll also have to factor this scale for our width, and it looks like that should be it. Now you have a fast one where you can supply a scale which is factored onto whatever your default scale is going to be.